Hey guys, welcome to Machine Learning with me. Till now, we have learned about regression models and how optimization works using gradient descent. Now it's time to move into another major part of machine learning, classification.
So here's what we're going to cover. We'll kick things off by figuring out what classification actually is and how it's different from regression. Then, we'll get into the main types, see how it all works with something called a decision boundary, and wrap up with some popular algorithms and where you see them in the real world. Let's dive in.
All right, so first things first, what is classification? Well, at its heart, it's all about teaching a machine to sort things into different groups or buckets. The goal here is to predict a specific category, not just some random number.
Now, more formally, classification is a type of supervised machine learning. That word supervised is key. It just means we train our model using data that's already been labeled correctly. Think of it like showing a kid flashcards. We show it a bunch of examples and say, this is an A, this is a B, and so on. The model then learns the patterns from those examples so it can predict the right category for new stuff it's never seen before.
And this right here is the fundamental difference. You know how regression models answer questions like, how much will this cost? Or how many people will show up? Well, classification models answer, what kind is this? Is it this or is it that? It's a simple idea, but it's super powerful.
You literally interact with this stuff all the time. Your email client deciding if a message is spam or not spam, that's classification. A bank system flagging a transaction as either fraud or not fraud, yep, that's classification too. Even an app that identifies a picture as a cat or a dog is doing the same thing. In all these cases, the output is a clear, distinct label.
Okay, let's really hammer this point home by putting regression and classification right next to each other. When you see them side by side, the difference becomes crystal clear.
So here we go. Regression predicts continuous values. Think of numbers on a sliding scale, like a price, a temperature, or a salary. They can be pretty much anything. But classification predicts discrete labels. It sorts things into separate boxes. An item is either class A or class B. There's no such thing as being sort of in between. Now that we've got a handle on what classification is, let's look at how it breaks down. Really, it all comes down to one simple question. How many categories are we trying to choose from?
The simplest kind is called binary classification. And just like the name suggests, bi, meaning two, there are only two possible outcomes. Is it yes or no, true or false, spam or not spam? The answer will always be one of two distinct choices.
But of course, not every problem is that simple. When we have three or more possible outcomes, we're in the world of multi-class classification. A great example is a model that recognizes handwritten digits. It has to pick from 10 possible classes, 0 through 9. Or think about an e-commerce site sorting products into categories like electronics, books, or clothing. Okay, this brings us to what I think is the most intuitive part. How a model actually learns to separate all these classes. This is where we get to see the so-called magic behind the scenes.
So let's just ask the question directly. How does a machine learning model look at a big mess of data and actually learn to draw lines between different groups?
Imagine we plot all of our data on a simple graph. Each dot represents one piece of data. Now to us, it might look like there are a couple of different clusters, but right now the computer just sees a random collection of points.
This is where the supervised training part comes alive. We show the model the answers. We color code the points and say, okay, computer, all these blue dots belong to one class, and all these red dots belong to the other. This is the training phase, and it's where the model starts to notice the patterns.
The model's entire goal, its mission, is to create what we call a decision boundary. You can think of this as the line it draws in the sand, a clear separation between the different classes it's been shown.
And there it is. The algorithm looks at where all the red and blue points are and figures out the best, most optimal line to split them. From now on, anything on one side of this line is considered one class, and anything on the other side is considered the other.
And here is where it all pays off. When a brand new, unlabeled data point comes in, the model does something really simple. It just checks which side of the boundary it falls on. Since this one landed on the red side, the model confidently says, that's red. And that's it. That's the core logic of classification in action. So now that we understand the whole idea of a decision boundary, let's zoom out a bit and look at the actual algorithms that create these boundaries, and more importantly, where this stuff is used in the real world.
You know, there are a bunch of different ways to find that decision boundary. Data scientists have a whole toolkit of algorithms to choose from. You'll hear names thrown around like logistic regression, k-nearest neighbors, support vector machines, and decision trees. We'll explore these in detail later, but for now, just know that each one is a different strategy for the same job.
And where is all this used? Honestly, it's pretty much everywhere, working behind the scenes. It's what's powering your email spam filter. It's helping doctors with medical diagnoses. It's a huge part of how banks analyze credit risk, and it's the core tech behind image recognition and the recommendation systems that tell you what to watch next.
So if there's one big idea to walk away with today, it's this. Classification helps machines make decisions, not just predictions. It's a subtle but really important distinction. It's about making a judgment call. This was an introduction to classification in machine learning. In the next video, we will start with logistic regression, the most fundamental classification algorithm. So be with us and subscribe for more such content.